Hello and welcome to my channel. I am Mensa Augustine. In this lesson, we'll be looking at GCE Further Mathematics Advanced. That is called Pure Maths 1. And this is paper 1. And we'll be looking at question 3. So let's see how we go through this question in a very simple way. If you are new here, kindly subscribe to my channel. And if you have been watching my videos and not yet subscribed, please kindly subscribe for us to board the mathematics community. Now, before you go through, make sure you read the instructions very well before you tackle the exams. So now let's see what we're gonna have here. Wow, this is question 3. So how do we answer question 3 in a very simple way? We have that determine the general solution of the differential equation cosine of x dy dx plus y sin x equals e power 2x times cosine squared of x, giving your answer in the form y equals f of x. Given that y equals 3 when x equals 0, determine the smallest positive value of x for which y equals 0. Join me as we go through this step by step. So what do we do? What we're going to do first is to divide through by cosine of x. So if we divide through by cosine of x, we are going to get dy on dx plus y. If we divide this one by cosine of x, we get tangent of x equals, if we divide this one by cosine of x squared will remain cosine of x. So we have e power 2x times cosine of x. Wow. So now we find the integral factor. Say u of x equals e power the integral of, this is our p of x. So we take tangent of x in a very simple way, dx. Now for this integral, you can use u substitution. That is, tangent of x is the same as sin x on cosine of x. But integral of tangent of x is also a standard integral, which is equal to ln of secant of x. So this becomes e exponent ln of secant of x, and here e will cancel ln and we have secant of x as our integral factor. So we take the integral factor and multiply it through this. So we're going to have secant of x dy on dx plus y times secant of x times tangent of x equals, now if we multiply here by secant of x, you know that this secant of x is simply 1 over cosine of x. So multiplying this one by secant of x is the same as multiplying here by cosine of x. And that cosine of x will cancel this. So here we'll be left with e to the power 2x in a very simple way. Now, what do we do? If we look at the expression here, you see that this expression is nothing but simply the derivative of the derivative of that is y times secant of x. You see that if we want to differentiate this, what do? We keep y constant and differentiate secant of x. That will give us y times secant of x tangent of x, and then we keep this secant of x also there and differentiate y with respect to x. That will give us secant of x dy on dx, and we add addition as the product rule. Wow. So first we keep y, differentiate secant of x to get secant of x tangent of x, then we multiply it by y. Secondly, we keep secant of x, we differentiate y to get dy dx and then multiply it by secant of x. So if I integrate what I have here, I have to go back to this because the derivative of this will give me what I have here. So I can write here as y times secant of x equals the integral of e to the power 2x dx in a very simple way. Now, how do I integrate this? You see that for this integral, you just consider this and then differentiate. Wow. If we differentiate this, let's say we have u equals 2x, we have du on, okay, let's say du equals 2 dx and du on 2 equals dx. So this will become the integral of e power u du divided by 2. So which means we can factorize 1 out of 2 out here. So dividing here by 2 is the same as multiplying the whole thing by half. Now, if we integrate e power u with respect to du, we get the same e power u. So this gives us half e power u. But u is 2x, so we put 2x there in a very simple way. Plus the integral constant c equals y secant of x. And what do we do? We need our answer in the form y equals f of x. That is what we have here. So we need to divide through by secant of x. Now, I've already said that secant of x is the same as 1 over cosine of x. So this is the same as y times 1 on cosine of x equals half of e power 2x plus c. So let us multiply each side by cosine of x so that this will cancel. Wow, so now we have our answer in the form y equals half of e power 2x plus c times cosine of x as y equals f of x. Now, we have that we've been given that y equals 3 when x equals 0. So y equals 3. So we put 3 here equals, then we have half of, when x is 0, 2 times 0 is 0. E power 0 is 1. So 1 times half is half plus c. Then cosine of 0 is 1. So we multiply the whole of this by 1, we get the whole of this. So here we just take half from 3. That is 3 minus half equals c. And what is 3 minus half? We get c equals 5 out of 2. Wow. So we can write this as y equals into half of e power 2x plus 5 on 2 times cosine of x. Wow. We found the constant, right, in a very simple way. So determine the smallest positive value of x for which y equals 0. So if we put this y equals 0, what do we get? It means that we have to put the whole of this equals 0. Now, if we take this one to be equal to 0, we have half of e power 2x plus 5 out of 2 equals 0, which will give us e power 2x equals negative 5. That is, if we multiply through by 2, we get this. Now, e exponent 2x can never be equal to negative. So we cannot proceed through this path. Now we take cosine of x equals 0. That is cosine of x equals 0. Then x equals cosine inverse of 0. Now for cosine inverse of 0, we have 90, 270 going, but the smallest one is 90. Now if we change 90 into radians, we get x equals pi on 2 in a very simple way. I hope you've enjoyed the lesson. Thank you for watching. Please like, share, subscribe, and leave your comments for us to build the mathematics community.